Tonight we are going to do the hexagonal beam, and I got to tell you, I spent all week here working on this because I've never had one, and I wanted to learn more about it and find out more about it. So what I did was I spent the week learning about it, putting together a slideshow and everything to talk to you guys.
Then I'm sure
about
you know what this is.
There you go. There's your base plate.
Yep.
Yep, which is about 80 or 90 bucks probably, and I suggest buying one rather than trying to make one. Also, your standoffs, you might buy those too. They're about 200 bucks. There's and we're going to discuss all this tonight as we get into this. So there's a lot to this, and we're going to discuss it. Before we get into that, I want to mention I've been doing a lot of FT8 this week. I've got 9,100 contacts right now. And I've got a little deal going with myself. I'm trying to make 10,000 contacts by the end of the year. So I've been working the bands up and down every day trying to make contacts, and I've made about 80 or so today. I've been working a lot of 80 late at night, and although it's not an unusually long band, it's been doing really good late at night. And 40 has been fun. 20 this morning, I got on 20 a little earlier than I normally do, and I hit Australia. Just like that, boom. FT8, not voice, but I hit Australia, and it was really cool. So you never know what you're going to get. I was kind of running that gray line, you know. Anyway, and then I will tell you guys, we have been seeing some pretty wide openings on 15 and even 12 sometimes in the afternoon. So just wanted to put that out there for everybody. We're hearing a TV or something in the background. I don't know what it is. I'm just letting everybody know. All right. No, there's gone. Okay. There we go. Let's see here. Tonight, does anybody have anything on propagation from the last week?
6 has been open a little bit.
Really?
Yeah, in the afternoons. I keep, it's open a little bit now, but only from like Tennessee area and up towards Chicago. But this morning, I keep DX maps on and I keep it switched to 50 megs on the monitor up the top there so I can keep an eye. I did a shout out twice on FT8, but nobody came back to me. But there was a guy making contacts up into the Midwest over on the East Coast, but it didn't appear we could get it here from the West Coast of Florida. That was today and yesterday, during the day.
Yes, 6 and 10 seem to do their best work in the middle of the day, whether it's magic band or regular propagation. But I will tell you guys that I've left my 6-meter beam up because we've got a little mini magic band season that comes right around Christmas.
Yeah.
So we're going to be watching that. We're going to be doing magic band updates for the next month or so. Maybe
from any time now onwards.
Right.
Anytime, it seems to be after Thanksgiving. It's like the weather up north, you know, like everything's good until Christmas, and then the weather knows it's Christmas, so after Christmas it turns to gaga or goo-goo, whatever you want to call it. At least like the magic band seems to wait for Thanksgiving and then opens up until maybe, if we're lucky, the middle of January. That's my kind of impressions anyway from here.
Yeah, I'm looking at it up here. The right now at night, there's nothing going on. There's a little bit in South America, but really nothing. But over on the day side right now, it's wide open on 6 meters from New Zealand into Eastern Australia right now.
Yeah, there you go.
And also there's people making contacts from New Zealand all the way up to Japan. And there's a lot of stuff in Japan. So that 6, you know, when it runs, it does run. And you can actually see the cloud. I ask you guys, if you're ever watching the PSK Reporter and you're looking for magic band stuff, you need to look for where all the lines cross. And that's where that magic reflective cloud is. And that's where you got to shoot your beam. All right. Let's see here. What else is going on? I don't know of anything else going on. I did get the newsletter out this morning. We'll be going through that in just a little while once we get the main topic out of the way. Does anybody have any announcements or anything right up front they'd like to talk about?
You don't forget the swap shop tomorrow.
Yes, I have that later on, but we'll do it now too. The swap shop is tomorrow. I plan to be there, but I'm not sure. I got a sick wife and a sick mother. No, I'm not one sick mother. I have a sick mother. I didn't make sure you guys heard that right. But no, and my back's out. So between it all, there's nobody healthy over here until you get down to cats. So yeah, it's pretty rough right now. It's not good. I'm telling you guys. I haven't shaved in a week and a half. I just don't care.
Can't cook and wait on you guys.
Yeah, I know. Well, we're their house cleaning staff, so that's not going to happen. But anyway, yeah. So I decided I was talking to Rick the other day, and we both have kind of an affinity for the hexagonal beam antenna. And I wanted to just mention before we get into it that Joseph may or may not be in tonight. He's in the process of moving. He's in Huntsville right now unloading trucks. So if he makes it in, that's great. If he doesn't, I am prepared to both pilot and navigate this evening. So, all right, let's see here. So I got talking to Rick last week, kind of after the net, about the hexagonal beam, and I believe he's putting one together right now. So I thought, well, this would be a good topic for tonight because I want one too. And if you have one and I don't, I'm probably envious. I actually think right now that the hexagonal beam all around is the best HF antenna you're probably going to find, at least for 20 and up. It gets really big and cumbersome above 20. And we'll discuss all that later too. But for 20 through 6, or at least 20 through 10, there's different schools of thought on 6. A lot of people are saying it doesn't work well with 6 when you string it up with all the other bands. I don't know, but
I went with the 20 through 10. I had a friend up in Atlanta who's got this same model. This is the KIO hex beam I've got here. I went ahead and bought the whole thing, but he said that it did not. If you put 6 meters in here too, it would interact with the 12 meter. I thought, well, I would like to have it to be fully, capable at HF. I've got a 3-element 6 meter beam anyway, so I'll put that up separate.
Yeah, I've kind of already decided to not put the 6 in mine either because I have a really nice 6 meter beam. It's a 5-element beam, so there's just no sense in me putting 6 meters in this thing. But because it does interact with some of the other bands that are down near it. It also gets the spacing gets really tight down there, and it becomes a lot more critical when the more wires you put on it. I'm actually looking myself at a 20 through 10, just like you are, and we're going to go through all those options. I want us to, if there's no other announcements or nothing else anyone who wants to talk about, Rick and I are going to take you on a little journey here through the hexagonal beam antenna. And let's see here. All right, here's our first slide. Everybody can see that all right? All right. Okay, we're going to discuss tonight the hex beam. Why the hex beam? What's a hex beam? Construction material options for the hex beam, and step-by-step build instructions. And then we're going to also talk about information on purchasing one instead of making one. I'm a home brewer. But let me tell you something. Even if you buy this thing, it's still, you got to put it together. There's still a lot of homebrew here.
There's going to be a lot for me to do.
Yeah, there's still plenty for you to do, even if you buy the $1,000 one. Yeah, so we're going to talk about all that because what's neat about this is you can buy the kit, or you can buy just the cheese and pepperoni, whatever you want. And we're going to discuss all that in a little while so that you can see exactly what you want, how far along you want to go. Like the base plate, I buy that every time.
Yeah.
The separator pieces that go up, fiberglass, they need to be a certain tension, a certain strength, this and that, yada yada yada. They're $200.
Yeah.
That's probably the only other thing I'd buy. Everything else I can get locally or I can build myself. But those two things specifically, and we'll talk about that. let's see here. Let me get back to this page. I think therefore I am. You guys know that's my little saying here. And embrace the hobby and all its wonder and delight. And don't get bogged down in the politics. God knows we all hate politics right now. All right. Tonight we're going to talk about several different designs. This is a homemade one right there that you're looking at. It's completely homemade. It's on a ladder. Huh. It's an extension ladder. He's got it mounted on that. He puts the ladder up. He puts standoff. You know, he puts the cable, the guy wires down from the ladder, and he's got his beam up there stuck in the only hole of sky that he has. And what a neat thing that he built there. And that's all a homemade one. And I don't think he has a lot of bands on there. I think it's just a few. You can make one just for 17 if you're a CBer. Okay, let's see here. I don't think you can mix 17 with 15. What is it? 15, 18. You know, when you get CB in there along with the 3 or 4 that we want to put in there, they're too close together.
You're talking about 11 meters then.
11 meters. That's what I'm trying to say. Thank you.
Yeah, I was going to say.
You cannot put. I said the wrong. I'm bad with numbers, guys. You have to forgive me. But the 11 meters CB, you can't really get it in there. It's too close to 10. And then, of course, you got 12 right there. And it's just the wires are like this close together, and they're going to interact with each other. And again, it wouldn't work. So, but you can build one just for CB, and it should work for 11 meters or whatever I'm calling it this week. All right. Tonight, we'll look at a great design by this guy, EI7BA. And he's the one that sent this picture, and a build plan by these guys. And I actually have that on the downloads page. So you'll be able to download that tonight. And I'll show you just how to get to it so you can download your own build instructions. I was going to make build instructions, found these, said not reinventing the wheel.
Yeah, no point in that.
No point in it at all. Okay. Nope. What's a hex beam? A hex beam, or it's also called a hexagonal beam, is a type of directional antenna for HF. It's just a 2 compact element beam folded back so that it occupies less space. You have to look at this thing as a fancy Yagi. It really is just a fancy Yagi. And instead of the elements coming straight out, you have a driven element and you have a reflector in the back. There's no directors. It's just a driven element and the reflector in the back. And the reflector is bent around this way, and the the driven elements are in like a V. And you can see it right up here in this diagram. This is such a cool thing. This to me is like the space age antenna. We've arrived. This is it here. And if it doesn't work, you can stretch fabric over it and use it as an umbrella. Yeah, it doesn't it look like an umbrella that got caught in the wind?
Yeah.
Believe it or not, some people actually call it. It's also called a wire beam antenna, and also an upside down umbrella antenna. So it can be called all different things, but the hex beam is kind of what ham guys have settled on calling it. Yeah. It may also sometimes be known as a W antenna, referring to the shape of the driver. So there's 5 names right there that you can call this thing. I suggest hex beam.
The original version was 2 W's.
Yes, it was. And we're going to discuss that on the next slide, I believe. Yeah. There was the hex beam, and then there's the broadband hex beam, which is what you're looking at right here. In the original one back here, these went up and down just like the front ones. Yeah. It was totally different. So, but when you go to this design, it's 20 meters, it's 3 foot wider. But that 3 foot, okay, makes it to where it's a lot easier to make, because all these wires here don't have to be strung up and back out again. And I'll show you that in the next one. You can build it as a multi-band, or you can build it for specific bands. I'm thinking about I'm not going to be able to afford to buy this stuff to build this for a while until I get a big job or a big production deal or something. So, and you know how it is in my business. One year I make big money, and the next year I'm barely getting by. It all depends on what work comes by that I can get. So for right now, I'm probably going to build me a 10, 12, 15 out of common stuff. I'm going to build it out of a, and I'll show you in just a minute, but I'm going to build it out of a wood buck, like off a wire spool.
Yeah.
And I'm gonna build it short. It's not gonna be that big because it's only gonna go up to like 12 or 15. It's gonna be a little one. But anyway, so let's go to the next slide here. You can build your own. Why a hex beam? Well, here's the big thing about the hex beam. If you're a wire user like me, I got a big old wire strung through the yard. Don't work worth the crap. It's all under the trees. This thing is directional. You put it on top of a rotor, and now you're directing and you're excluding. The directing is really, really important. The excluding is really, really important. When you've got a city right behind you, like to me, when I'm shooting north, I've got Fort Myers right behind me. I got North Fort Myers right behind me. I got everything behind me. I have nothing in front of me but woods. So I have a great takeoff, but I got all this noise right behind me. So this thing's something where I can shoot it towards the northeast, and I can exclude all of that local noise that's right behind me, or a lot of it anyway. And so the fact that you can not only push out your transmit range a lot further, bring in your receive range a lot further in front of it, the big point is you can exclude it going in the back. You're taking the energy and putting it all out the front, so you're not really sending much energy out the back when you transmit. And just like that, you're not receiving much of the QRM that's coming in from the back, just because you're near a city or there's a power line nearby. If you got a power line right near the shack like I do, you should be able to. I'm going to be able to aim this thing towards Texas and put that power line right behind me, and I'll be able to hopefully be able to eliminate some noise. You can get 5 or more bands with low SWR with this new design. With this, the new broader band design, you can basically get a really good SWR across the entire band, as long as you've tuned it. Basically, you've cut the length of it so that it's in the middle of the usable band. It's a wide enough bandwidth that you can use this antenna all the way across the whole band without a tuner.
Try to do that on a regular Yagi.
Yeah, or anything for that matter. It's difficult. Yagis, as much as I love them, can be finicky and not as wide as you'd like them to be. This thing has a very wide bandwidth, which I think you can get. In other words, you can get a really good SWR all the way across our legal band where we're allowed to operate. So that's great. Whether you're going to go do FT8, then you want to go from there up and do voice. You won't have to get a tuner. You won't have to do anything. It's all going to work just from there. It's got broadband characteristics, low weight and low wind load. That's nice. Down here, you still need to take this down for storms. It's not going to be something that's going to take 100-mile-an-hour winds, and we'll discuss that in just a second. Construction from general hardware components, yes, with caveats. This thing is, if you're building it for 20 meters, this is something you can't just build with household crap, okay? It's going to have to be a little better than that. It's going to, and we'll get into that too. Ease of adjustment. It's pretty easy to tune this and make it a little tighter, a little looser, and to make adjustments on it. Requires less space to set up and use. This is a huge one for me. I got a big hole right over my house. I'm going to be able to put this thing up in that hole and get it up above the trees, up at 35 feet or so. And that's going to get, I guarantee you that's going to give me 3 times what I'm getting now on this wire that's stretched underneath the trees. So I'm looking forward to it. I can't wait to get one of these things. Just a couple of questions and answers here. Are the wire links critical? Yeah, if you change the wire length for the reflector on 10 meters by 1 inch, it changes the design frequency by about 130 kilohertz. So it does. It's just like any other antenna. We're going to make it big. We're going to make it a little bigger than we're supposed to. We're going to cut everything a little long, and then we can tune it down. You're much better tuning with a tuner than you are with a tape measure. If anybody'd like to comment on that, I'd appreciate it. No? Am I right? I guess I'm right then. You could tune it with a tape measure, but you're better off with a tuner. How high should the hex beam be? The higher the better for DX generally, as it reduces the takeoff angle for the main RF lobe. However, the hex beam can be quite effective even at modest heights. Everything I've said, 40 feet seems to be pretty much optimum. Higher than that begins to have, what do they call it? Limiting results, I guess you would say.
Diminishing
Diminishing
return.
results. Thank you. Yes,
Yeah.
diminishing returns over 40 feet. Under 40 feet, you start to have fairly good drops in performance. However, there was a guy showed one of these that was mounted 3 feet off the ground, and he's out there making contacts all over the world with it.
It was no taller than the somebody were using it for a clothesline.
It looked like a clothesline, yeah, and I was like, that's pretty cool.
Some British friends would call it a washing line, but
It affects your takeoff angle, and it
yeah,
also eats up some of your juice. But if you can't get it up on a tower, you could sit this thing 5 feet off the ground on a picnic table in your backyard and hook it up.
yeah,
And it'll work because it doesn't use counterpoise. It's all built into the antenna pretty much.
yeah.
So the main thing is just getting it away from the ground. All right, let's see here. Yeah, they don't handle wind that well when you get over about 60 miles an hour.
And they don't handle ice very well either.
Yeah, that one on the right was taken out by a ice storm, I think, and then and possibly the one in the middle too. The one on the left was like hurricane damage.
Yeah,
But they're like anything else. You know, it's a sail up there. Look, the good news is there's no fabric or anything to really catch the wind. Most of the wind flies right through it, but you got to watch out for that. Here's what we were talking about. This is what Rick was talking about. Originally, they called this thing the hex beam or the hexagonal beam. That was this one here. The one I'm suggesting you make is this one over here, which is the broadband hex beam. Notice the difference. They make a big deal. It's 3 feet wider. I don't care. If it gives me a much better SWR all the way across all the bands and better performance even, I'm definitely going to build the one on the right, even though it's a few feet bigger. It's not that big a deal. Anything on this, guys? Rick, have you used the other one or anything about that?
I haven't used the other one. This is my first experience with it too. So I'm just, I'm not going along for the ride. And just, if there's anything I know, I'll pop in here. But I did want to bring up the original design, and then of course the newer design, which is wider banded. The diameter, like you say, there is 22 feet. So your turning radius is like 11 feet from the rotor. So that's how big it is.
Which, if you think about it, it's not crazy. Now, you want one that does 30 and 40. This thing's going to be this thing's going to be over your entire house. It's going to look like somebody's going to think you're putting up a sunshade for your whole house. It goes up to like 43 feet, I think, when you go up to 40 meters.
Yeah.
44 feet. There is kits that big. You can get them. I've never seen one for 80. I don't. That have to be some commercial rig. But
well, that's kind of like my 160 meter J pole. It would be ridiculous.
That's right. Well, or you could also go to orbit on it.
Yeah. You'd have to have FAA approval to put that.
And a blinking red light.
Yeah.
But anyway, the construction of the broadband is easier than the classic because you don't have to stretch all these wires back like this. The wires just go around. And on this one here, you had to have spacers here on both sides. With this one, it comes around and there's just basically an isolator there that's so many inches, and that's in the design plans. You'll see it. There has to be an isolator there to isolate the end of your driven element from the end of your direct reflector element. Okay, let's see here. So basically, guys, this side is your positive side or your center lead. This would be and it doesn't matter which side. This would be your negative lead or your what do you want to call it? Your jacket, your
the shield,
the shielded lead there. And then this back here is your parasitic reflector.
Electric.
It's not hooked to anything. It's neutral. Okay, any questions on this? All right. Tuning is not that critical because the bandwidth is broader. Reflector drivers and spacers are single loop, making adjacent. That's what I just told you about that. This is a lot easier than making this because of they separate right at the thing that comes out, and you have to have two separators. With this, you go around through the turn pin, and then you have one separator. It's actually a lot easier to make this one, and you don't have all that turn crap in the back. Okay, let's a quickie. We have already kind of talked about this, but this is basically how a Yagi works. So you guys understand how a Yagi works. So I'm not going to spend a lot of time here. But basically, you're gonna get most of your feed from the front, and that's the most important thing with this. I think everybody understands the Yagi. This is something you definitely want to use with a rotor, unless you live in a corner of the earth. It's a flat earth, so maybe you live in the corner. Well, that's going back about 8 shows, isn't it?
Yeah.
But anyway, we don't really think the earth. Disclaimer: we don't really think the earth is flat.
Will it make a difference if you're in the left corner or the right corner?
As far as your center lead and your outer lead, it doesn't.
No, the corner of the flat Earth.
Oh no! As long as you're near Antarctica, that way there's nothing behind you.
There you go.
Oh, okay, yeah, that's right. There we go.
Yeah, because Antarctica goes all the way around the Earth. But over here on the right, that's what the lobe looks like. I want you to notice how flat the back of this lobe is. It's like, don't want it. This is a great lobe. And again, you need a rotor because, and you know, when I say you need a rotor, you don't need a rotor. You can turn it yourself. If you're putting it up in such a way that the center pole comes down, and you can just go out there and turn. I have stuff I turn manually.
That's the Armstrong
method. Yeah.
Yeah. And what you're supposed to do when you're turning it, you go, and that way you think you got a rotor. Okay, let's see, spreaders. This is probably going to be one of the hardest parts of this thing is you got to have spreaders. The spreaders, they recommend against PVC because it's a little heavy. But the other part about PVC is you get too much sag. This needs to be straight, and then it needs to fight against the curve. PVC tends to sag against the curve, if you know what I mean.
Yeah.
And it doesn't really give you the right shape. You're going to have issues with it. I think if I were going to work with PVC, it would be on the smaller. Like I'm going to build me a smaller one out of 3/4 inch PVC.
Yeah.
But I'm going to build like a 10-12 that I can just play around with. And I'm going to stick it up on top of my dual Yagis at 30 feet and start spinning that around and see what I can hear on it. Fiberglass tubes are recommended for the spreaders. They need to be 136 inches in length for 20 meters. I would base your design on 20 meters. Any bigger than that, it gets crazy. Any smaller than that, you lose 20, which is the band.
Yeah.
Okay. And 20 is resonant with 40, so you can throw a tuner on 20 and you can probably use it with 40 and 80 through a tuner. Your lobe may not be perfect, but it will still work and you'll still get some performance. Now, let's say, what's the best thing for my spreaders? Well, here you go. I think this is probably going to be the best thing for spreaders is to just buy them. They're $200. I am the cheap guy. I do everything on the cheap. You know that. I researched this week, and I could not find a viable alternative. One guy built one out of fishing poles, but it didn't work that well. One guy built one out of PVC, but it didn't work that well. And finally, you know what? Everybody I read got to the bottom and said, just buy the $200 spreaders.
Yeah.
Just buy the $200 spreaders.
That's Max Gain Systems. So I actually happen to know the guy that owns that. From Atlanta, and they've got a $150 set, which they got on back order. The $200 is already it's already black. So, yeah, that's new.
Yeah, there is a couple of options out there that are a little cheaper than this. As far as Max Gain Systems, the only reason I bring them up No one had as much stuff out there. They have all the parts to build everything. Max Gain Systems.
Yeah.
So I would just check them out and then also price it out. Check eBay. I
Yeah.
found a base plate. Well, I'll show you that in just a minute. We're going to get to
Yeah.
that. Let's see here. This is the kit. This is the kit. Their kit comes with this. It's one tube into another tube. It's basically 3 tubes.
Yeah. And that's
Each
what
one
you
is
get.
each one is graduated down or whatever.
Yeah, that's the way mine is. I think
Right.
same source.
And there's the link. But like I said, if you just put Max Gain in there, you'll find it.
MGS.
Now let's talk about center plate. You can buy them like Rick did, which is what I would do. $55 right there on eBay. DX Engineering has this one that looks like they used it in like a Transformers movie or something. But that thing's pretty cool, man. I don't know. I don't know what that is, but that thing's pretty cool. So there's some different options out there, all the way from the cheap to the expensive. Or on the left, if you're going to build a smaller one like me, start out with a buck and build it with a wood buck like this. A buck is off the end of a spool. Joe,
Yeah.
I don't know if Joe has any extra spools out there. We usually keep the spools, but that's all that is a buck off the end of a spool. I didn't know that's what it was called until I read that this week. It's called a buck.
Fuck. Okay. That's a new one for me too.
Me too. You learn stuff on this show.
That's
Anyway, go ahead. Did somebody have something? All right, guys, anytime you have something, butt in. I don't see hands. I don't see the little fingers. So anytime you have something, I want you to butt in and make sure I don't miss you, okay? All right.
Using the pizza tin as the centerpiece, but I don't think it would be strong enough.
No, well, unless you're building one for 2 meter.
There you go. 2 and 6 or something.
2 meter sideband. Big
Yeah.
thing right now. Not.
That's a possibility.
You know what? I've played around with it, and I think there's something to it. I think that we could probably. I think that there's actually stuff to 2 meter sideband. There's actually people on 2 meter sideband. I leave my machine on sometimes on my 40-foot Ringo, and I leave it on upper sideband 2 meter on the 2 meter USB channel, and I'll wake up in the morning and it heard 3 or 4 people overnight. Now, I don't know if I'd have made a contact with them. Most of them were in Florida somewhere. But I just thought it was cool that if you leave it on long enough, it will hear somebody on something. All right. The wire that you're going to use. Well, the Max Gain sells wire that works perfect. I don't know why. Why is my camera blinking? Blink, blink. What are we doing here?
I don't know. You got some kind of flasher over there.
Okay, there we go. Max Gain Systems has this wire that you can buy. It's just basically uncoated, unshielded copper wire. Now, the other option you have is what about using steel wire or aluminum? It does slightly affect your SWR performance. So, I'm not saying one's better than the other. I'm just saying for some odd reason, it does seem to affect your
It
SWR.
also affects it. Now, what I've got here is insulated. This is the insulated flex weave stuff, but that's what came with the K4KIO kit, which is what I purchased. So, and it's going to be a slightly different length. When you use the insulated wire, it has a slightly different velocity factor, so it has to be tuned.
And also, can you use stranded or solid wire? Either is fine. It doesn't matter. The gauge is a little bit important. If you go up or down in gauge, you can also affect your tuning as well. But again, if you make it long and cut it to tune using your analyzer, I tell you guys, if you're building one, call me. I'll come over one weekend and I'll bring mine over and we'll analyze it. The MFJ, and mine has the joy button for 400. I know yours does too. These things right here are. This is like looking in the mirror and trying to shave. Which side's it on? This thing right here is probably the best thing I ever bought. It is. It's an amazing thing for tuning. And when you make this thing, you cut it 3 or 4 inches long, and literally everything's done by tuning. Don't ever make an antenna cut to length. Always cut it long. I don't care if you're making a 2-meter dipole with coat hangers to use with your scanner. I don't care. Tune it. Make it perfect. Cut it 1 inch long, and then go and put it where it's going to be. Bring your antenna tuner as close as you can get to it, and then just start trimming the top and the bottom of that down till you get it tuned perfectly to what frequency you're going to be on. Okay, and like I said, you don't have a tuner, get with us. Rick has one, I have one, Joseph has one. The Nano VOs, the Nano VNAs work. Also the MFJ tuners, and there's also other ones out there that are good too. So definitely get with one of us, and we'll help you get that tuned. Insulated wire can be used, yes. And rope, you're going to need to use some kind of rope. Now, I'm going to tell you, in Florida, if you use any kind of just any rope, I had some rope laying around, it's a ticking time bomb. You really need to spend a few dollars and get some of this, the Dacron, however you guys want to pronounce it, the UV.
It's going. That's a 1,000-foot spool. I got one of those headed over here. Also, make sure you use stainless steel hardware. Very important. You know how much it rains in Florida.
Does it? Yeah, it does. No, you're absolutely right. The better you can build this hardened for outside, the better.
Yeah.
And that even includes, when you're all done, going up there with electrical tape paint or whatever and painting all your connectors, and the whole thing's going to have to be protected from weather. And all this stuff can be bought at Max Gain Systems or at about 20 other shops. I'm not plugging a specific one. I got these pictures from here, and every time I put in parts for a hex beam, their website kept coming up. So I don't know if it's just Google, or maybe they're the leader in it, or maybe it's just Google search results, but that's who kept coming up. So that's why I put the logo there. All right, let's go this way. How do we make our connections? Well, there's a bunch of different ways, okay? The lower right, that's the lower long picture there with 2 different things. That shows you one way to do it, where you actually put the wire strap or whatever underneath the radiator clamp. Is that what you call those, radiator clamps?
Yeah.
For lack of a better word, I don't know.
Like. Yeah,
I'm a nerd, not a mechanic.
Yeah.
And anyway, you put that under there, and you clamp her down, and that gives you, and your wire can run right through there. Look at that, right through there. And then here's your other setup there. This is another way you can do it. You get some tubing, and you can use these little copper straps that you can buy over in the electrical department at Home Depot. And you can copper strap, make a little loop that holds your little piece of what is that? It's probably a fish tank piping, fish tank air hose. And you just put a little 2-inch piece of air hose on there, and there's your insulator. It goes right through. It runs perfectly through there, and it makes a great little insulator. So there's some different ideas there of different ways you can make your connection points. Or if you're buying kit stuff, if you've got money, unlike me, you can buy this stuff all set to go. It comes numbered in a kit and everything. And trust me, on this one, I would buy it if I had the money. Because this one, I'm gonna tell you guys, this is the hardest thing I've ever talked to you guys about building. This is not an easy one to build. But I don't want to discourage you. All right, there's different ways to do the wire. If you're using a piece of PVC, which is what I'm going to probably use, I much prefer putting my antennas on a non-conductive mass. It seems to increase performance quite a bit. You can run your wires. You come down from the top. You're supposed to come down from the top. I guess you can go up the back, or I don't know. It said you're supposed to come down from the top. I don't know. I guess there's you use magic in there somehow.
Yeah.
But anyway, you come down from the top, and then you're gonna hook into your different wires for your different bands. That top one's gonna be 40, whatever, or
They'll
20.
be 20 usually.
Yeah, 20, and then going on
17,
down 17, 15,
15.
and then notice 12 and 10 are pretty
Yeah,
close down here.
they're pretty close
This is
together.
another way you can do it. This is the way they actually suggest you do it, which is kind of what he did here too. You used coax between your connection points. See that?
Yeah.
Over here, this one's a little harder to see, but they didn't use coax here. It's just like automotive wire or something, which works, but that doesn't look right to me. It's not shielded and all that
I
like it's
think
supposed
that's
to be.
coax. It's just the way they've got it all dressed up so that it will withstand the weather.
Well,
Make,
these are like horseshoe connectors, and
yeah.
there's a red wire and a blue wire. I don't know. It's kind of hard to tell on that picture, but when your wiring goes on this thing, this is how it needs to go. You need to cut pieces and do it like that. And then when you're all done, you paint the crap out of it with electrical paint, and then come back and spray it with paint, whatever you got to do to protect it. Should you connect the bands with wire or coax? They suggest 50 ohm coax.
Yeah. RGA.
Do I need a balun? A balun? Yes, they suggest it's a good idea because the surface current flowing on the exterior of the coax, distorting the radiation pattern. The best price for a ferrite bead balun I have found is there's a suggestion there. There's different ones, or you can just wrap like I do. You just wrap your wire a bunch of times.
You can roll your wire several times, or you can get some ferrite beads. Now, like these guys, this is Leo Shoemaker's model. He sells a kit of beads that you can buy. You don't have to buy anything else. You can buy that. But he sells the kit, but you need to have it. Otherwise, the directional pattern will be distorted. And then you're probably going to get RF in the shack and all that good
Something
stuff.
like this work, or does
Yeah.
it need to be?
Oh yeah, that's what this is. It's let me see if I can find the kit.
You guys see that? It's a you just put your wire through there, you loop it around one time and close it down.
Yeah, this is the kit. Right
That's
here.
a ferrite trap.
Yeah.
You can use these to stop line noise on lines. You could use it to stop distortion on TVs, distortion coming up through your power lines. There's all kinds of different things that it will help
Gets
you
rid
with.
of RF in the shack and that kind of thing.
Yeah, it's a good deal. It's a really good deal. All right, let's see here. Next thing, actually, I should have turned the screen off so you could have seen me there, but that's all right. You guys know what a ferrite bead looks like. All right, this is just a breakout. This is the same sheet of paper. It's just left and right. This is the bottom half over here. I couldn't fit it all on the screen. This is just kind of a breakout to show you all the different parts that you're going to need. Again, I've got the full how to build it. I'm going to show you how to get to that in just a minute. This shows you how your wires hook up. See how it brings the wire up, and you start at the top and go back down again.
Connect to the top.
And this is a ring that goes at the top to hold all the 6 wires that go out to the ends to hold them up. That can be accomplished probably more inexpensively than that. You could probably just tie the wires up there. You would need to have some way to keep them up there, but you can do it. There's the plate you need to make with the U-bolts, but this shows everything. Here's your measurements. And what I suggest is when you build it, this is all in that guide. My goal tonight was to not have you ready to build when you walk out, but to know if you're going to build or not.